Hello. Usually when I'm running DV tapes for customers, I'll run them on Sony equipment. If they're the small tapes, typically I use camcorders because they also support long play. But sometimes I'll use the Sony DSR11, which is a DVCAM deck and also supports the larger tapes. But you know, there are other manufacturers of DV equipment, and a while ago I was working on a Panasonic NV DV2000, but unfortunately it needed a part which is unobtainable. It would be nice if I could demonstrate that there were other useful players in the DV market.
Special delivery.
Oh, I wonder what's in this. It's pretty big, but I believe there might be a DV deck in this.
Special delivery.
Oh, smaller. We have another one. So 2 DV decks to play with. Let's get stuck in. Okay, starting with this smaller package. A JVC BR-DV3000U. Nice. And this one will take both a mini DV and larger DVCAM size tape. So that's particularly useful. Really, it looks like this one replicates the functionality of the Sony DSR11 quite accurately. Okay, the front panels slid off when I took the bubble wrap off. It may already have been loose, so we'll have to look at that. And it takes 12 volt DC input. Looks like a similar connector actually to what the DSR11 uses from Sony. So we've got audio and video. Oh, let's have a look. Channels 1 and 3, 2 and 4, so it can handle up to 4 channels. I think the DSR11 is 2 channels only, but handles them in pairs. So left and right, in and out, or channels 3 and 4 in and out. Composite video we won't use, and YC, importantly DV in and out, and NTSC PAL. I think that's going to be record only. I think for playback it'll automatically switch to NTSC, I think. Let me just sort out this front panel a little bit. Okay, we have some loose screws here. It's obviously been apart a few times. Right, that's going to require a little bit of TLC. I also need to find out exactly what the power supply requirements are. It's got a very basic VU meter at the front with just 3 LEDs to give you some idea if there's a signal, which is better than the DSR11 that doesn't have any of those, and some remote control options. So in some ways it's slightly better featured than the Sony equivalent. Okay, we'll put this to one side for a minute while we unpack the bigger box. Starting off with a remote control, which seems huge. Oh wow, what a wonderful remote control. Though that's gone quite sticky and horrible. Maybe that'll clean up. That is a fantastic remote control. This comes with some fault description. Heavy patterning, PSU, clears eventually. SPLP break up until warm. So it really sounds as though there's power supply trouble on this one, doesn't it? Shall we plug it in and have a quick look at it, see what this patterning looks like, and then we'll dive straight into the power supply, I think. Now, remember when I have one of these, it was a dead loss because a gear had broken up inside, which was extremely hard to replace anyway, and unobtainable. Put the tape in, and it sounds like it's about to play. Wow, that is some patterning. Yeah, that's quite severe patterning. I can't even make much sense of what image there is under there. Right, let's switch it off promptly, I think. Let's have a look at the power supply. I don't remember much about this machine. It was some time ago since I last worked on one. Okay. Interestingly, many of the capacitors are on one board there, which appears to be unpluggable. but still we'll have to look at the other capacitors that remain on the bottom. It looks like in order to access the main board you have to strip the whole machine down, which is a bit of a nuisance. Superficially, all the capacitors in here look fine. None of them are bulging. Okay, so what's involved in getting the main board out? It looks like probably just have to take the deck out and then undo the screws and remove it. Okay, we've undone these ribbon cables, and there's one connector here for audio, I think. Okay, so pull these levers up and then you can pull these cables out. That's it. So there was one screen cable at the back, and then these three that go flat cables that you pull up these tabs from. Right, so we have the deck out, and I believe the deck is good on this one. Now we have to remove the main PCB, which I think is going to involve taking the back PCBs off as well. Yeah, all this could have been a lot easier if they'd made it so you can access underneath, but they didn't. If after all this it turns out there are just millions and millions of bad capacitors in here, it's not going to be possible to go through every capacitor in here. It would take an absolute age. There's literally hundreds. We'd end up having to do something like put the better deck with the better electronics, but that's not a good solution really. Right, we now have good access to everything. The only trouble is it's a little bit fiddly to hook everything up to test it. So we're just going to have to work through these capacitors, testing them. Now the big problem, as I've said before, is it's all well and good testing them. You can either test them on the board, and I have a foot switch remote control operation on this thing, which is handy for testing on the board, but very often capacitors have routes through to other capacitors, maybe via inductors, so you may not get real readings from that. If you desolder the capacitors to test them, then very often the heat will at least temporarily reform the capacitor, and the reading you get isn't genuine. So that's always a decision you have to sort of deal with when testing capacitors on boards. Alright, let's remove that plastic shielding. I'm just going to check this capacitor, the filter capacitor here, for voltage, and I will not short it out. I do not think that's a good way to discharge them. I always use a resistor. Call me a coward, but I don't like blowing sparks around on circuit boards. And it doesn't do the capacitor any good anyway to be short-circuited. Okay, about 8 volts on there and decaying, so that's absolutely fine. But if it was like 300 volts on there, I would not be shorting that out. Now, the first capacitor is not normally to blame, the one right after the rectifier, though I have had one fail and it broke a printer. It says 68 microfarads, 400 volts, so I can test that one. 97 microfarads, which is ample, so that one is not to blame. Never thought it was. It's the wrong kind of patterning. If that goes bad, you get mains hum, but this is high frequency noise, so if it's in a power supply, it's on the secondary side. Does this daughter board plug in, or is that just a way of... Is that just soldered in? It's a little bit hard to see exactly what kind of connector this is. Let's just test some of those capacitors, bearing in mind that they may be paralleled with other components. But that's 1200, 1200 and 820 microfarads. I can't measure it in circuit. Similarly, so I'm going to have to take these out, I think. Yeah, I'm not getting readings, useful readings out of those, so let's see if I can take this board off. Okay. Maybe we can make measurements on that now. That's the 1200, that's not miles away. Hope you can read that. Another 1200 to read. Yep, again very slightly low, but I'm not going to worry about that. And then the 820. They're all very slightly low, but not low enough to upset circuit operation. This one should be 820. Again, very slightly low. This one should be 1800, slightly odd value. Close enough. Should be 100. Close enough. Not sure, but I think this is another 100. Yep. 1800 again. Good. And 470. Well, we don't have any smoking guns in power supply capacitors that I've found so far. That's interesting. Could we have bad capacitors somewhere in this sea of electronics? That would be unfortunate in the extreme. I'm going to somewhat offline test a few of these. I can't easily get them on the camera and test them at the same time, so I'll just test a handful and get a feel for whether those capacitors look any good. Alright, I've started making a few measurements, so just looking at a few capacitors here, like these black ones which are mostly lower value. If I just look at them in circuit, they seem to be working fine. I'm not worrying too much about precise values at the moment, just to see if they seem to be in the order of things. Everything looks like most of them are okay. But then I moved across to some of the slightly, generally higher value ones, these Elner branded capacitors. And here we go. So here's these are brown coloured rather than the black ones. And whatever the capacitance is, the ESR is over 20 ohms. And again. And again, okay, it's in circuit, so it's struggling to read the actual capacitance, but it should still have read an ESR value in most circumstances. Move over to some others on some different parts of the circuit over here. And I think, and very rapidly it becomes evident that we're in trouble. All these Elner branded capacitors, or nearly all of them, are shot. Okay, that one's okay, but most are shot. Yes, most of them are bad. So, what would you do? How many of them are the brown Elner type capacitors? Well, nearly all of those along here, most of these along here. So I'm guessing about 40, 50 capacitors there. That's assuming all the black ones are okay. So far they seem okay. But there's also a possibility of other capacitors hiding elsewhere on different boards, such as in here. And under this screening can. So the total amount of those Elner capacitors that would have to be replaced is huge. So I'm afraid, therefore, I believe this machine to be an economical write-off. It's not as though it's an incredibly rare format and it's especially worth putting vast amounts of work into. If it was something obscure, a weird format, then it would maybe be worth a bit more, but it's just an ordinary DV deck. I don't think it's practical, and worse still, you could replace all those Elner capacitors and then the thing still not work for some reason. So I think this one's a write-off. I'm going to reassemble it. There could be more capacitor trouble on the main board too, though I doubt it. Now you might say, well, I could fit this deck into my other machine of the same model which had mechanical problems. But having seen how bad the capacitors are on this, I suspect that the other machine will have capacitor trouble too, that would only become evident once we got the deck running. So I don't even think it's worth doing some part swapping, because I'll just finish up with another, at best, unreliable deck. Oh well, let's just reassemble it. It's not going to work out. Okay, next to the JVC BR-DV3000. So here's the power supply I've borrowed, which I believe is compatible with this. It's 12 volt sensor positive. There was a slightly unusual jack. These are used on various things. This one I believe was from the DSR-11 DVCAM machine from Sony, but actually is being used on an ADVC 1000 DV firewire bridge. Anyhow, let's first see if it physically will fit the socket. It looks right. Okay, and it's 12 volt center positive. That's all promising, but the state of this machine, I don't reckon it's going to work. So before we power it up, I'll get it ready to power up, but before we power it up, I think I'll take the lid off and just take a look inside. Right, there's lots of missing screws and incorrect screws, which doesn't bode terribly well. And the front panel is sort of a bit loose, as we saw earlier. I will put it back on so I can find which button's which. Okay, I think we're ready for switch on. It looks like it's intact. Okay, the interior doesn't look as bad as the exterior. I'm not seeing anything glaringly obviously wrong inside. The pinch roller is in an odd place. It's up here, so that must drop down. Right, I've checked my power supply, 12 volt center positive it is. Let's plug it in and give it a whirl. Okay. I don't know if that's normal or not, but the PAL light is on. It was a bit slow taking the tape in. It's flashing the tape LED. Wasn't happy about something. Why wasn't it happy? Try again. It's gone off. Oh, it's on. Doing something weird now. The operate light's flashing, and I heard the fan slowing down. It sounded like it was tripping out. Now, I'm sure this power supply is more than capable of driving this thing. Well, it says 1.3 amps. Do you think this could take more than 1.3 amps? I don't think it should. Actually, the specifications might say. It says power consumption 14 watts, 1.17 amps. So our 1.3 amp power supply should be just about sufficient. We've got a lot of light in here, and since it has optical sensors, that might be upsetting it. So I'll turn down some lights, maybe cover it up a little bit, and try again. Just switch it on. It's flashing the operate light. Is that normal? I have to read the instructions. It's not taking a tape in. It's power cycling again. So I can get into the standby condition with the tape in. At least that's normal. If I hit play, no, you need to press operate first and then press play. See if I can get it to even attempt to play. I'm just going to have a look and see if it's tripping out the 12 volt power supply. Can I get to the 12 volts anywhere? Okay, it's off at the moment. There are two terminals which I think are ground and one supply. So let's just confirm that those two are ground. Right, and that would be supply. Okay, so let's measure that voltage on the supply pin. 12 volts. Let's switch machine on. I don't know what it's doing, but the 12 volts seems to be remaining. Behaving differently on its side, isn't it? The mechanism appears to be okay actually, but it's just confused. But the deck seems to be working properly. I'm going to press eject. Yeah, eject, did eject. You know what though? I'm just holding it there and I'm feeling heat. I'm feeling quite a lot of heat. Right, let's crack out the thermal imaging camera. This is a Topdon TC004 which I reviewed a while ago. It's a wonderful piece of kit. You can't expect it to solve all your electronic problems, but when there is something funny going on with something overloading or taking excess current or generating too much heat, this is very handy. And that part of the board does seem to be getting quite hot. And it looks like it's on the other side of the board, whatever's generating all that heat. I don't suppose I can get to it. Let's have a look. It's on the other side of that. Underneath this board, something's getting very hot. There's also something getting pretty warm here. Okay, so there's a transistor there getting very hot, but it is a power transistor of some sort. But there seems to be a humongous amount of heat coming out from underneath. You can actually see it glowing through the gap there. Let's take this board off. Unfortunately, I have to unplug this board to get out of my way, so I'm going to have to work quite quickly before it cools down. Right, before it cools down, what was the part that's generating all that excess heat? If it is excess. So I'm still reading some 30 something degrees Celsius on the hot spots, which appear to be these inductors. Doesn't look like a smoking gun, does it? Again, extremely hot inductor. Well, extremely hot, it's about 30 Celsius, but considering how long it's been switched off. So is that normal? Do those inductors get that hot? It just seemed unreasonably warm. I could actually feel the heat coming off the PCB on this side. But there's no real way of having it all connected up and get to that bottom PCB. Well, take the bottom PCB off, I suppose, but that's non-trivial too. Well, I think we're going to have a quick look at some capacitors on the main board here. Just get a feel for whether they're going to be a disaster area like the Panasonic. Let's look at some of these 100 microfarad surface mount capacitors here. That looks good. They're all looking sensible so far. That's a 33, that measures good. That's supposed to be 10, yeah, that's good. So it doesn't look like it's suffered from mass capacitor failure. Alright, let's refit this board. It's a fairly fiddly thing to work on. Okay, I've refitted them, but I'm seeing a little bit of damage on one of those connectors, and I didn't do it. Let's have a look at that under the microscope. So look, if I've messed up, I'll admit it, but I don't think I did that. Looking at that cable, that appears to have been a bit ripped up. Is the contact underneath it still good? Well, possibly. So I suspect that's happened when someone's disconnected the board. So that's one of these two flat cables. The smaller ones. There's a big one over the top here, and that's fine. But there's two smaller ones underneath. That looks a bit scrunched up at that end. The other end looks okay, and then the second of those two cables is also a bit scrunched up, though less so. There's a bit scrunched up there, but less so. I'd be surprised if that didn't work. So possibly a little bit of damage to that cable. This other small one's okay. I'll need to refit that. You put the flat cable in and then push down on the lever. It locks it in place. Okay, let's try it again. I'm sure it'll be the same. Power it up. Keeps doing weird things. Why is it doing that? It's very hard to know what's cause and effect, isn't it, when you've got this sort of behaviour. It has to, you can operate the motors here. This is obviously a professional thing, okay? You can override a jammed condition, which is something that's very much appreciated when you have, you know, some sort of crisis. You need to be able to get a tape out of a machine. You can do so with these motor overrides. So in this case we're going to use it to put the tape in the machine. Okay, so I haven't got the tape in the machine. Keep it in the dark a little bit. Power it up. Press operate. Ejected it. And then it takes the tape in, starts a lace, abandons a lace up, tries again to lace, abandons lace up. Doing crazy lacing and unlacing behaviour. Mode switch trouble maybe? Doesn't feel like it is a mode switch problem, because it wouldn't behave as sensibly as it does then when it does succeed in lacing. Because it takes a tape in and does some tape shuffling, which all looks entirely normal. Let me try and get you to see that. Okay, so the tape is laced but the power's off. When I power it up, it might be perfectly logical for it to unlace. Let's see what it does. Powered up. It's sitting there with the operate light off. Switch operate on. Part lace. Abandon. Lots of shuffling around. Now it's laced. Looks like it's trying to read a bit of the tape. That would be sensible and normal. Sitting there waiting for play, but then instead of waiting for play, it unlaces again. See, I don't think it could do that if the mode switch was bad. It feels more like an electronic fault to me. Alright, press eject. Which does work. Can we get to the mode switch, or is that too hard to find? It looks like it might be relatively easy to take the deck out with these screws, though we might have lots of cabling trouble. Maybe it's worth a try. And does it come out complete with this PCB? Maybe. Okay, that was the way to gain access to the hot parts underneath. So where do we think the mode switch is going to be? Wherever it is, it's going to be extremely hard to get to, because taking this PCB off is a no-no. Not really, because you'll mess up the actual deck alignment. End up retiming that. Looking at the service manual, much of which is in Japanese, this gear here is the mode sensor gear. So the mode switch will be immediately under that gear. Not terribly easy to get to. And I think the mode switch is actually just built onto this PCB. I'm going to apply a little bit of switch cleaner around there in the hope that it will reach the contacts on the other side of the board. Okay, let's just try it again. No, it's mad. Let's just try to reject the tape. Which does work remarkably well, actually. Okay, I've just left the thing powered up for a while, partly to see if it just stabilizes, and partly to see if anything is actually getting really hot. So, I mean, I do feel quite a lot of heat coming off these, well, apparently these coils. I'll just put a thing on that. Okay, not that hot, but we'll look at them in a minute. So, firstly, let's just try a tape now. It's been sat here for about an hour or so. Oh, it's still all over the place, isn't it? Listen to it. Vroom. Oh, I've actually got it playing. Good heavens. Stop. Play. Oh well, let's hook it up to a monitor and see what we see. So we select play. You can hear it's not well though, can't you? And a few moments ago it was playing. It's behaving like it's got power supply trouble. For a moment there, we momentarily see some broken picture. So we're actually getting some playback. Just hit pause, and we're getting a valid pause. So it's showing signs of life, isn't it? I wonder if this power supply is struggling to power it. What do you reckon? Should I try a beefier power supply or hook up 12 volts from another power supply? I might do that actually. Okay, I've soldered a 12 volt wire. That's plus 12 volts there. And I'm going to connect up my power supply. Which I've configured for 12 volts and it's about 2.5 amps. I've set the current limit. Okay, let's try that. We can read the current here as well. So it's drawing about 800 milliamps at the moment. Let's press play. Almost an amp. Still lots of errors. I think behaviour is very similar. It's drawing about an amp in picture search. Loads and loads of errors. Let's see if mechanically it runs better now. So that's eject. Let's see if it'll take the tape in cleanly. That does seem a bit happier, doesn't it? Okay, maybe this power supply wasn't up to the job. So there's an awful lot of errors. It's actually saying head cleaning required. Okay, let's actually just put a head cleaner tape through it. Okay, a few more tapes to try. DVC Pro, it should fit, but whether it will be able to play it's another matter. Let's try a cleaning tape first. I'm watching the current consumption. It does seem a bit heavy at about an amp. Run the head cleaner tape through for a few moments. Okay, try another tape. Still lots of errors. Yeah, the sound's dropping out and there's occasional picture breakup. Let's try this tape. Firstly, just to make sure that it is working for large size tapes, but I don't think it will actually play what's on the tape, but that's fine. So it moved the real tables apart for the larger size tape. And then it shut down. And then it shut down and died. My wire fell off. I'd been a little bit overcautious with the amount of solder I used. Okay, where were we before it all fell apart? Switch it on and see what it can do with the DVC Pro recording. Probably nothing. Just ejected the tape without being asked to. It's almost like it can see the tape, it understands what kind of tape it is, and it knows that it could record on it, but it finds that it's got a recording on there that it can't play, and so it's just spitting the tape out. No, doesn't like DVC Pro. Okay, so be it. Now, I could do more if I had the original remote, because you can go into the service menu and look up various things, including head hours, which I'd like to see. But unfortunately, it doesn't have buttons to override those functions without a remote. Some Sony equipment does, but not this one. I'll just leave the tape playing for a while, just in case it's nothing more than a bit of head contamination that might clean up. With this tape, it's playing it fine, apparently with no errors. But other tapes, and I checked this is not a long play tape because professional machines won't necessarily play long play. Other tapes keep playing with errors. So it implies something's a little wrong. I'm going to look at the FM envelope if I can. It's on the rewrite board. TP9 is the RF signal and TP5 is the head switching. Let's do that. See if I can get to those test points. I haven't yet found the test points for getting the envelope, but what I have realised is that this is a menu button, and by holding that with no tape in, we can get to some menus and hopefully see the hours meter, which is something I want to see. So, do that. In the no cassette condition, press and hold that for 2 seconds whilst keeping stop or play button pressed. 1, 2. Oh, good. I'm starting to understand it. Hours meter, that's what we want. $218 hours. That's not times 10, that's actually 218 hours. Well, the heads aren't worn out then. Right, we can switch the error rate measurements on with something called dip switch 1. Right, now we can play a tape and have a look at the errors. So let's start with the one that was giving me more or less no errors, which is actually a tape I'd recorded. I don't know if you can see it, but our numbers there, 33, bouncing up to a few hundred. Going down to like 40. If the error is over 4,500, then it triggers the head cleaning required message. So numbers around about, well, we just got one of 7 and 9 and 4, do imply that the heads are reading this tape okay. And let's try one of the troublesome tapes. It happens to be an NTSC recording, but that shouldn't matter. Yeah, it's huge numbers, thousands and thousands. You don't need to flick the PAL NTSC switch, do you? I'll flick that switch to PAL, but I'm sure that won't, to NTSC, but Well, I've switched over to an NTSC mode on the back. Surely it doesn't need that set. Right, what it's telling me there is channel 1 is full of errors and channel 2 is fine. Look at it. We're getting figures down as low as 4 on channel 2, but channel 1 is thousands. Okay, so we know channel 1 head is where our problem lies on that tape. We're getting numbers that are very similar on both channels. 11, 20, low numbers on channels 1 and 2. Even as low as 0 on channel 1. So that implies that our tape is the problem. But the fact that so many tapes are giving us trouble just doesn't make sense, does it? Because the tape that we were struggling to play on this just now plays fine on another machine. But with error counts as low as that, I'm not going to start fiddling with the tape guides to reset the RF waveform because they're clearly fine. Trying some different tapes. Here's another tape that's giving me lots of errors on channel 1, but it came from the same place as the other tape that gives us lots of errors on channel 1, I think. And another tape from elsewhere, and we're getting fairly high readings on channels 1 and 2 for this one, of around about sort of 1500 or so. Though visibly the tape looks okay, we are getting high error counts, high-ish. Isn't this odd that it seems to be so fussy, and yet with some tapes the readings are perfect. This is a tape I recorded a couple of years ago when I was debugging a problem on a computer. I just left a camcorder looking at the computer screen. Turned out to be a firmware issue actually. Those errors are just tiny. Channel 1, 1 error at one point. So with readings like that, you'd say there's absolutely nothing wrong with the machine. But it seems unusually fussy. And when it was having problems, it was sometimes having problems with just one channel. And of course the tape guides would affect both channels. So it doesn't imply that it's an FM envelope problem. Well, it turns out there's a very good reason I can't find the rewrite board, CK453008B. It's because it's a service component that I don't have. You plug it into a socket down there, and then you gain access to the signals. I've never before seen a machine where you have to have an extra PCB to work on it. And for a professional piece of equipment, I'm really disappointed in that. I'm stunned that JVC did not include access to the FM envelope signals. They must be somewhere on the main board underneath, but it's so compact it would be extremely hard to find them. They've just made that really unnecessarily difficult. So we won't be looking at the FM envelope after all. We just have to rely on the fact that we're getting very low values when at least playing this tape for the error counts. So that implies it's a good machine and that all my recordings are the cause of the error counts, which after all you don't normally get to see on most domestic machines. But it is particularly fussy about playing some of the tapes, and the error counts are way too high and it's just not playing them cleanly. Okay, I think we'll stop there. So the JVC, I need a better power supply for it, but I'm still getting problems with high error counts on some tapes. I don't know if there's a fault with this machine or not, and I can't readily access the FM envelope to just make sure that that's good. I'm going to leave it there for the time being. Anyway, there's some cosmetic work to do. I would, at the very least, try and sort out some screws for the cabinet and get the front to stop falling off. I might do that anyway. Right, the Panasonic was a dead loss, millions of dead capacitors in this. Tell you what though, the remote wasn't, because it turns out there's a setting here for different VTR settings, and I was able to get that to work with a Panasonic Super VHS machine, and it actually does work properly. I've cleaned the horrible stickiness off this. It works fine for the functions it has, but there's no tracking buttons on here, and a lot of the Panasonic machines only have tracking on the remote control. So it's of some use, but not hugely helpful. And by the way, I did try this on some Panasonic professional machines, DVC Pro decks, but they don't have the infrared detectors, so they won't work with this. But it's a fantastic remote control, and maybe one day I'll get a machine I can use that with. Right, I've heated the plastic tabs that hold the front on, so they are shaped inwards properly now, and the front's staying on nicely, and fitted new screws. Okay, they're not black, but they're all matching and they fit properly, so the whole case holds together properly. Now, the power connector, as I mentioned earlier, is the same I think is on the DSR-11, and it's a slightly odd one in that it has a male pin in the middle rather than the usual socket. So I've ordered some plugs of that type, and I've ordered a nice beefy 12-volt power supply to go with it. So that will have a decent power supply, and it's cosmetically all sorted out, including some rubber feet and everything. So not too bad now, but we still have the problem that it's fussy about what tapes it plays. But I still think I'll find some use for this, even with that difficulty. Something else I was working on recently was a semiconductor analyzer, and I complained that it didn't plot the Zener breakdown voltage of a Zener diode, and apparently I'd missed a tick box on the menu screen. So let's just fire that up and see if that's the case. Right, so we have a 6.2 volt Zener diode, and we'll test it. And it measures it there, 6.176. Now we go to the PN junction, and it was set to forward, but if we set this down to reverse on the bottom left and then hit start, we should see it conduct at 6.2 volts. So there we go. I was wrong, and the tester does properly plot graphs for Zener diodes, but only up to around about 7 volts. Somewhat limited voltage range, but still useful up to that voltage. Right, I hope you've enjoyed us messing about with these DV decks today. Over the next few weeks I've got some things going on. It's the summer holidays and what have you, so I won't necessarily get to do a video or full-length video every week over the next 2 or 3 weeks. But don't worry, I'll be back shortly with lots of long content video on mostly audio and video technology, but you know, I will be doing some interesting other things. I've got a couple coming up which are other subjects which I hope you enjoy. Bye for now.